Hey guys, in this session let us see the high level architecture of Oracle database. Oracle architecture consists of two major components. One is instance and the other one is database. Instance consists of memory structures plus a set of background process. Memory structure include shared global area, which is SGA, private or program global area, which is PGA, and user global area, which is UGA. And background process include, you can see small rectangular black boxes, right? All these boxes represent background process. Okay, and background processes are of two types. One is critical and other one is non-critical background process. Critical background process are the one which is blinking in red color, and non-critical background process is the one which is in white color. And let me explain each and every background process. LREG is the one which registers the database service with the listener. Okay, listener registration process. And in previous versions like 11G database versions, PMON is the one which registers the listener database service with the listener. But due to high load, PMON was having some issues in 11G database version. Hence, Oracle introduced listener registration process in one of the 12C version to reduce the load to the PMON. Okay, and coming to MMON, MMON is manageability monitor, which is very helpful in generating the snapshots required for the AWR report. Okay, specifically for the performance diagnosis reports. Okay, so this will keep on taking snapshots of each and every happenings in the database. Okay, and it will store the contents of the particular statistics into the disk. Okay, and whenever you require the performance reports, you will be generating the AWR report, right? Automatic workload repository report, right? So all those reports can be generated with the help of MMON background process. And coming to MMNL, MMNL stands for Manageability Monitor Light Process, which is similar to MMON, but this will help in generating the ASH reports. Okay, so in case the ASH contents are stored in the memory, if those contents need to be flushed from the ASH buffer to the disk, then this MMNL is the process which helps in managing the active session history reports. Okay, so active session history means this report will take all the samples. Okay, AWR report will be based on timings and ASH report will be based on samples. Okay, and coming to RECO, RECO stands for recoverer process, which is very helpful in recovering the distributed transactions in case of any failure. Okay, and coming to SMON, SMON stands for system monitor, which is very helpful in crash recovery of your database. Okay, say for example, if you have a laptop which contains Windows or Mac or Linux OS, in that case, if you are abruptly shutting down your system by plugging off your main power or switching the main power button off, okay, in that case, what will happen? The next time when you start up the laptop, you will be having some checks, right? Some blue screen error or some drive errors or something like that. So there will be some disk checks to check for any corruptions in your system, right? Because your system was running and it is accessing all those drives, and you are directly plugging off your main power, then what will happen? Obviously your drives get corrupted, right? So likewise, if you are abruptly shutting down your database, in that case, the next time when you start up the database, there should be some process which need to recover your database from any bad sectors in your disk, right? So in that case, SMON will read the read log file and perform the crash recovery. Okay, and SMON will also help in cleaning up the temporary segments. Okay, so if you have sorting or hashing operations in your temporary segments, in that case, all those sorting will be performed temporarily, and those temporary sorting operations need to be cleaned up for the next sorting operation. Okay, so SMON is the one which will clean up the temporary segments in your temporary table space. And coming to PMON, PMON stands for process monitor, and this process monitor is the one which monitors other server processes whether they need to be restarted or not. All these checks will be performed by process monitor, and this is very critical background process. Okay, as I already told, in 11G version, PMON is the one which also registers the service with the database service with the listener. But in 19C version, PMON will only monitor the other critical background process for any failures and restart them if needed. Okay, so always you check the status of your database with the PMON. Okay, whether your database is healthy or not, you have to check the PMON process whether it is up and running or not. Okay, and coming to checkpoint, which is CKPT. Checkpoint is a process which maintains the consistency between the control file and the data file. Okay, so there will be a sequence control or system change number which will be recorded in your database for every change happened in your database. Okay, and this SCN needs to be recorded in the control file header and the data file header. Okay, for consistency. Okay, this checkpoint is the background process which maintains this consistency and synchronize both the control file header and the data file header for any if any data recovery is needed, or if there is any inconsistency between the database. Okay, so control file is the one which stores all the information related to the database, like the database name, database ID, and when the database was created, what are the locations of the data files, and what are the locations of the redo log files. Okay, all these information will be stored in the control file. Say for example, your data file is located in this location in the disk. How you will identify? With the help of control file. Okay, in the control file it will record that the data file is located on the bottom of the disk. Say for example, just assume it, and this data file is located in the top side of your disk. Okay, likewise, just assume it that your control file will be recording all the information. Also, the backup related information will be stored in the control file. Okay, and coming to SP. SP is server process which will be reading the data blocks from your data file. Okay, and it will save it in the database buffer cache. Okay, and coming to DBWR. DBWR will write all the contents of the database buffer cache to the disk. Okay, so DBWR is database writer process. So here you can see a lot of blocks, right? So all these blocks need to be returned to the data file once. Okay, so let me come to database buffer cache so that you will understand. Okay, the main goal of DBWR is to write the contents of database buffer cache to data file. And coming to PMAN. PMAN is process manager process which will spawn or stop or manage the queuing process. Okay, all the job related process will be managed by process manager. And coming to LGWR, which is log writer process. This process writes all the contents of log buffer to the online read log file. Okay, log buffer contains all the changed records. Okay, and there are three conditions when log writer writes the buffer contents to the online read log file. For every 3 seconds, the buffer contents will be written. For every 3 MB of the log buffer gets full, the changed records will be returned to online read log file. And when the user execute a commit, then all the blocks will be flushed to the online read log file. Okay, and online read log file contains multiple groups and members. Okay, and this online read log file work in a switching mechanism. Okay, when first file gets full, the records will be switched to the other file, so that the other file will hold the records of the contents of the log buffer. And when the second file gets full, the contents will be written to the next file. Okay, and again it will go to the first file. Likewise, it will work in a round robin fashion. Okay, and all the contents of the online read log file will be returned to the archived log file with the help of archiver process. Okay, since this is a symmetrical file, all the three files will be are of same size. Okay, but archive log file will not be same size. It will be differing in size. Okay, so if the first log file gets full, those contents will be returned to the archive log file. Okay, and this archive log file will be very helpful in recovering the database. Okay, if you want to go to a previous point in time, you can use the archive log file to recover your database. Without your archive log, you cannot go back to your previous state. Okay, if it is a production database, then it is necessary to enable archive log. Okay, if you are not enabling archive log, then your database cannot be recovered to a point in time. Okay, you can also disable archive log if you want, but if it is a production system, then it is very necessary to enable archiving so that all the contents of the changed records in the online read log file would be returned to archived log file. Okay, and coming to recovery writer, which is RVWR, this process writes the contents of the flashback buffer to the flashback log files. Okay, if you want to go back to a previous timestamp, okay, in case you corrupted your table or your database, okay, in that case, if you want to go to a previous state even after committing the transaction, what you can do, you can use your flashback feature. So this flashback feature require undo to be retained. Okay, without the undo, the flashback feature cannot be useful. Okay, and so let us come to SGA. SGA contains shared pool, database buffer cache, log buffer, large pool, Java pool, and streams pool. Okay, and shared pool contains library cache, data dictionary or row cache, and result cache. And whatever SQL statement that you execute, all the SQL statement has to enter the shared pool, and it has to enter the library cache first. Okay, inside the library cache, parsing of the SQL statement will be performed, like checking whether the syntax is correct or not. So if you are not providing the right syntax, instead of select star from, you have used FRM. Okay, instead of FROM in your syntax, you have given FRM. So that is syntax error. Okay, all these error will be checked in the library cache, and hash value will be generated, and execution plan for that particular SQL statement also will be generated by the optimizer. Okay, so here the brain symbol denotes optimizer. Okay, just consider that in real time there is human brain, right? So human brain is capable of taking decisions by itself, and it has the intelligence to perform its own decision, right? So likewise, optimizer has the intelligence to decide the particular path to retrieve or manipulate the data. Okay, consider that you are situated in one location, okay, and you want to reach a particular destination. Okay, in this case, you will be having multiple ways to reach the destination, right? Okay, so consider that you are using Google Map to check for the fastest possible way to reach the destination. Okay, and the first path is having traffic in your Google Map. Okay, and the second path is very long. Okay, so it is very time consuming, and it is taking long time to reach the destination because of the distance covered. And third path is having some metro construction. Okay, so due to that there will be a lot of traffic, obviously, so this path also will be taking long time. And fourth path is the one which is the shortest possible way in your Google Map, so it is taking less time compared to other paths. Okay, in this case, what your brain decide, obviously based on the short time, it will choose the last path compared to other paths, right? So likewise, optimizer will be having multiple paths to retrieve or manipulate the data directly from the disk. Okay, say for example, if your Google Map is not updated for the last 10 years, okay, in this case you are having outdated Google Map. Okay, so you will be having the directions of before 10 years. But after 10 years, which is today, okay, you want to reach the destination today, right? So today there may be multiple constructions or buildings or multiple shortcuts or flyovers would have been constructed. Okay, in that case, there may be even more faster way to reach the destination, right? Say for example, if this metro construction was in progress before 10 years, okay, but today this metro construction is completed and people are actively using this metro for faster travel. But your Google map is not updated for the last 10 years and it is showing that this metro construction is still under progress. It is showing the outdated information or the wrong information. So this misguide you and tell you that this is the shortest possible way. But in real, the path which is having the metro construction is the shortest way. Okay. So why? Why? Because the Google map is not updated. So likewise, if your optimizer is not having the statistics, okay, recent or the fresh statistics, then optimizer will decide the wrong path, or we cannot say wrong path, but the longest path, okay, so that it will take long time to retrieve the data, right? So similar to how Google map is not updated, if your statistics is not updated, it will show the old data where the construction, metro construction is still under progress. Likewise, just assume it, okay. And like how you ignore the fastest path which is having the metro and you are still under a particular thought that the path which is having the shortest possible way is the faster path, but in reality that path was short before 10 years, right? So likewise, optimizer has multiple scans like full table scan, index range scan, index unique scan, right? So all these scans will be decided based on the optimizer statistics. Okay, without the recent statistics, optimizer will decide the bad execution plan, or it will take long time to retrieve the data. So that you will be having performance issue in your database or for the particular SQL statement. So it will take long time for the SQL statement to display the output. Okay, that is how optimizer work. Okay, and coming to data dictionary cache contains the number of users which are stored in the database, the number of objects which are stored in the database, and whether the user is having permissions to access the objects or not. All these information will be stored, plus the statistics. Okay, whether the optimizer, the statistics which is required for the optimizer to generate good execution plan. Okay, this was also stored in data dictionary cache. Coming to result cache. Result cache contains the cached result sets of a particular SQL statement. Say for example, if a particular table is having almost 1 million rows, okay, out of this 1 million rows you need to retrieve only 100 rows. Okay, so this has multiple filter, right? Why? Because you are retrieving only less rows from a large data set, right? And if this table is included in a select query, okay, and if that particular select query is being executed 10,000 times per week, so there are 10,000 executions per week. Okay, and also the data which is retrieved should be same for every execution. Okay, say for example, if you are executing the select query for the first time, then out of these large data set you should retrieve only 100 rows. Likewise, for second execution also, the data retrieved should be same. Okay, if these conditions are met, then only you can cache the results to the result cache. Okay, so this will be very helpful in data warehouse environment. Okay, where there will be a large data set and you will be retrieving only less data, and also the data which is retrieved also will be same. Okay, even if these conditions are not met, then also you can cache the query in the result cache, but still you will not get the benefit. Okay, maximum benefit will not be there, and the execution will be slow. Okay, so here why we are catching the result? To avoid IO. Okay, what is IO? IO is input output, which is an operation which whenever you try to access a particular data block from memory to disk, that is called as IO. Okay, so memory is separate component and disk is separate component, and to connect both memory and disk to retrieve the data, there should be an IO, and IO operation is very expensive. Okay, so to avoid all the IO operation, we cache the result in result cache so that you will immediately get the result faster. Okay, and under certain conditions. Okay, then coming to database buffer cache. Database buffer cache contains or stores multiple data blocks, which is by default 8 KB in size in all Oracle databases, and you can also change the default block size in your database. Okay, and these blocks are temporarily stored in the database buffer cache, and they will be periodically flushed by DBWR process. Okay, based on LRU algorithm. Okay, what is LRU? LRU is least recently used algorithm. Okay, so if a particular data block is not being accessed or least accessed, okay, if this data block is accessed only 1 or 2 times per week, consider. Okay, so then this data block will be marked as candidate in the LRU list to be flushed into the data file. Why? Because database buffer cache is a temporary storage, right? You cannot add another database buffer cache. Okay, but in data file, if you fill up one data file, then you can add another data file. Likewise, you can add multiple files. Okay, similar to how you are writing a particular topic in your notebook. Okay, so consider that you have a memory. Okay, so your brain is the memory, right? It will store all the learnings that you study in your memory with conscious and subconscious mind, right? So if you remember something, then you will try to remember that particular point. If you don't remember, then you will refer the notebook or the book, right? Either you read the book or you take the notebook and refer the notes that you have taken previously to again recollect what you have learned, right? So if you write one notebook and that notebook is full, okay, you no longer can write any other new data or new topic that you learned. Okay, then you will buy another notebook. Likewise, you will add a multiple notebook, right? From the shop, you will buy multiple notebook and write all the concepts that you study, right? So likewise, consider this data file. So this data file will be similar to notebook. Okay, and this database buffer cache is similar to our memory. Okay, so when this database buffer cache cannot store data blocks up to a certain extent, then they should be obviously flushed into the data file, like how you write it in the notebook, since you cannot remember a particular area or topic for a long time. Okay, if you are learning something today, you cannot remember that after 10 years or 5 years, right? So you have to again look at the notebook or book to recollect the topics, right? So in this case, you need to read the book, okay, if you want to recollect the data, or you need to write it in the notebook. So there are two operations, read and write, correct? So likewise, here server process will read the data which is stored in the data block in the data file, and DBWR will write the contents in the data file, similar to how you write in a notebook. Okay, and coming to this LRU, so there is most recently used or least recently used. So if a particular data block is accessed more number of time, say for example today this data block is being accessed 100 times compared to other blocks, then this block will be on the top. Okay, and this block will not be flushed into the data file. Okay, why? Because it is getting accessed frequently, and the data should be retrieved faster. So for that purpose, accessing data from your memory will be always faster compared to an IO. Okay, so that's why we store the block in the database buffer cache. And if this block is not accessed frequently, then it will be written to the notebook called data file. Okay, and so whenever there is a SQL statement executed in the database, first, as I already told, it will enter the shared pool, and all the SQL checks will be completed. Once the SQL checks are completed, what it will do, it will go to the optimizer generates the execution plan, and the server process will scan the blocks from the data file, and you have parameter called db file multi-block read count. Okay, we'll see it later. So this parameter determines how many number of blocks which can be scanned and saved into database buffer cache. Okay, and server process do this job. Again, say for example, if you are updating some records, consider, okay. Similarly, it will go to the shared pool for SQL checks, and it will optimizer will generate the execution plan, and server process scans the data block, and all those data blocks will be put into the database buffer cache. Okay, so in this case, if you are trying to modify a particular data block, okay, so this data block will be having a cloned block, okay, which is called read consistent image or old image of the original block. Okay, why you are cloning this block? Why? Because if you modify this original block, and in that during that time, if there is any data corruption or data failure, okay, then you cannot recover it, right? So for that purpose, in database buffer cache, for each and every block there will be a cloned block, okay, which is a read consistent block. So in that case, if you are trying to modify this data, and if someone is again selecting something from the same data block, okay, at the same time when another user is updating, in that case the select statement will access the read consistent image. Okay, so as I already told you, update will write the contents and select will read the contents, right? So in this case, if both happens at the same time, then the select statement will access the read consistent image, and the original block will be modified. Okay, when the original block is modified, that block or the changed records will be stored in the log buffer. Okay, log buffer is a circular buffer which keep on recording all the changed contents in this particular data block. Okay, so if you are updating a particular employee number, say for example, or employee name, okay, that employee name is stored in this block. Just consider for example, and once the particular block is modified, the changed record will be stored in the log buffer, and there will also be the old copy. Before you change, the read consistent image will be the old copy, and that copy will also be recorded in the redo buffer. Okay, and as I already told you, log writer will flush all the contents in the log buffer. So here log buffer contains all the changed records. Okay, so these changed records will be recorded in the online read log file, and again it keep on switching between each files, and if you enable archive log, that contents into the particular online read log file will be recorded in the archive log file. Okay, so this is how Oracle architecture work in a high level. And as I already told you, right, so there will be some IO buffer which will be allocated for performing some transactions. Okay, so if you want to read the data from the disk, there should be an IO buffer, correct? So for that IO buffer, this large pool will be used. Okay, so this large pool will also be used for Arman backup. So if you're taking backup for your database, for that backup there should be some IO channel, and so backup uses or heavily utilizes IO. Okay, so that's the reason a large pool is required. So this pool is very large, which is specifically used for IO purpose. Okay, and coming to Java pool, so Java pool is used specifically for Java applications. Okay, if your database is using any Java applications like Oracle Enterprise Manager or Apex or any other Java virtual machine, something like that. Okay, all the Java memory will be utilized into Java pool. Okay, and coming to Streams pool, Streams pool will be specifically used by a particular feature called advanced queuing. Okay, so if you are using data pump, okay, and you are exporting something using EXPDP or IMPDP. Okay, if you are performing some data refresh or data copy using data pump, then data pump will primarily use advanced queuing for its job queuing process. Okay, so all those advanced queuing memory will be utilized from Streams pool. Okay, also if you are performing any replication in your environment, like Golden Gate replication or Streams replication. Okay, all these replication softwares will be using memory from Streams pool. Okay, and coming to the left side, we have PGA, right? So PGA is the area where sorting and hashing will take place. Okay, say for example, if you are executing a select query with group by or order by class. So if you are grouping some data, okay, say for example, if you are grouping a particular employee who is having this much amount of salary, and you are ordering it in the ascending order, descending order, which employee is having the low salary and which employee is having the high salary, and which department he is, in this particular department, how many employees are having this much amount of salary. So these kind of sorting operations has to be performed inside this PGA. Okay, and if this PGA is not sufficient, then it will spill into the temporary table space. Okay, that is called swapping, right? So in Linux, you will be having some swapping concepts, right? If memory pages are not sufficient, and that memory pages will be swapped to the disk for temporary or secondary purpose, and all those data will be recursively accessed between memory and disk. And swapping is also very expensive, right? So likewise, temporary table space storage will be used, and SMON, as I already told you, in that case, once the temporary table space is utilized by the sorting, the space inside the temporary table space will be cleaned up by SMON process. Okay, and PGA will also store the bind variable information. Okay, and also the syntax of the SQL. Okay, and in dedicated server environment, you have UJ inside the PGA. Okay, in shared server environment, UJ will be inside SGA. Okay, there are two types of server. One is dedicated and another one is shared. Okay, in dedicated means the user process will be dedicated to a particular server process like this. But in a shared server, multiple user process will be sharing one server process like this. Okay, so that's why it is called a shared server. And why UJ is inside SGA in shared server? Why? Because the sessions need to migrate the information which is stored in a particular session, right? So if session 1 is performing some transaction, and all the information should be shared to the other session, that is called a session migration. Okay, so that's why UGA has to be inside the SGA. Why? Because SGA is shared global area, right? All the information inside the SGA will be shared to each other. All the SQL information or all the execution plans, right? But in a dedicated system, each and every user process will be having a server process, as I already told you, and all the user related information will not be migrated or will not be shared. Okay, they will be private to each other. So if I run some query inside the database, that query is particularly private for me. Okay, it cannot be displayed to another session, or it cannot be shared by another session. Okay, and this UGA contains all the user related information. Okay, like session info, what the session is performing, and who is the user and where the user is connected from. Okay, what is the terminal and what is the program, all this information will be stored in UGA in a higher level. Okay, and so here you can see there is user process and server process, right? So this user process first connect to the listener. Okay, listener will be up and running in the server process, and there will be a file called listener.ora and tnsnames.ora. Two network files will be there. Okay, these network files will be accessed by this listener. Okay, and LREG is the process which registers the database service to the listener, as I already told you. Okay, and this listener will be running, and user process directly connect to this listener with the help of the TNS entries from the tnsnames.ora file. Okay, and it will hit the port 1521, and the service validation and all those host name validation will be performed. Okay, once the validation is complete, the password file, okay, which will be stored in the database, will be accessed Okay, so here credentials will be validated. Okay, once both credentials and all the host name checks and service name checks and port number, all these validations are complete, then directly user process connects to the server process. Okay, here user process means application process. Okay, from application side there will be some process, and server process will be from this particular boundary. Okay, after this user process, all these server processes are from background. Okay, which means from database, right? Consider that you are using any application in your mobile or laptop. Consider you are using Facebook application. Okay, in reality Facebook may or may not be using Oracle database, but just assume it. Okay, once you give the credentials before you log in, the credentials will be validated from the password file. Okay, and similar to how there are multiple user processes which are displayed here, there will be multiple user processes which will be spawned by application process, and these user processes will be executing multiple SQL statements automatically with the help of any backend code like Java or Python or any of the programming language. And all these SQL statements which are executed will be having some pointer. Okay, this user process will be having some pointer which is pointing to the server process, and this pointer is called as cursor. Okay, say for example, if I'm opening this notepad, I have this blinking black line, right? So this is called as cursor. If I type in something, the cursor goes on the right side, right? So if I press enter, it is going down, right? So this is called as cursor in a notepad. So similarly, Oracle also will be having cursor allocated to each and every user process in the form of pointer. Okay, and this cursor will be executing the select statement or update or any other insert statement. Okay, then as I already told you, right? So let me recap the whole architecture. So once the user process validate the connections with the listener, user process directly connect the server process, and server process will be having the private area for each and every user, and this private area contains the bind variable information and all the private work areas for sorting, hashing, or bitmap merging. Okay, all the SQL work areas will be allocated in PGA, and UGA contains all the session related information. Okay, and this select query then will enter into the SGA, okay, from PGA, and inside the library cache, SQL checks will be performed like syntax check and whether the object having permissions to be accessed by the user. All this information will be stored in the dictionary cache. Okay, that is a semantic check, and if a particular query is cached in the result cache, then that will directly be used and the data will be displayed in the screen. But if the result set is not cached, then what it will do, based on the optimizer's execution plan, optimizer will use the server process to identify the blocks from the data file, and it will be stored in the database buffer cache. And inside the database buffer cache, there will be cloned blocks of each and every data block. Okay, and if you are performing some update statement, then that data block will be modified, and all the change records will be stored in the redo log buffer, and all the undo records which are changed, those data will also be stored in log buffer, and log writer will flush all the contents every 3 seconds and every 3 MB of the data stored, and if the user is executing a commit, and dbwr is a lazy writer which will flush all the dirty buffers. Okay, if a particular block is modified, then that will be marked as dirty buffer. Okay, in those cases dbwr write all the contents, and if there are no free buffers in your database buffer cache, okay, if your buffer cache is full, in that case, based on LRE algorithm, all the least recently used blocks will be flushed into the data file. Okay, and for every log switch, all the archived contents will be written to the archived log file using the archiver process. Okay, and if you enable flashback based on the undo storage or the undo retention, all the contents will be returned to the flashback log files with the help of recovery writer. Okay, so this is the high level architecture which I have explained you. Okay, and we have startup mount, startup open, and startup no mount. So there are three phases of startup modes in your Oracle database. So we'll see that in detail in the next section. Okay, so when you no mount the database using startup, first it will access the P file. Okay, then all the background processes will be started. Okay, in P file, the parameter related to database will be stored. If you want to influence your database, then there will be multiple parameters. So those parameters can be tweaked to make your database to behave in the particular way. Okay, so all those tweaked parameters will be stored in your P file. Okay, say for example, if you want to make your data file location over here. Okay, so where you will specify this? So you will be having multiple parameters to locate your data file, or you will be having other parameters to locate your control file. Okay, if you want your control file to be stored in this area, say for example, then you have to specify that location in your P file. Okay, and if you want to specify the location of archive log files, where your archive log files need to be stored. Okay, so there is flash recovery area parameter which will be making the archive log to enter a particular location. Okay, so likewise you have another file called SP file, which is server parameter file. Okay, so I will explain it later. Okay, so once the P file is accessed, then directly it will go to second one, which is mount. Okay, so in mount state, control file will be accessed. Okay, inside the control file, as I already told you, control file contains all the database information like database name, database ID, and the creation time of the database, and what are all the data file location. All these information will be stored. Okay, in mount stage, all these information will be read, and then it has to go to the open state. Open means all the data files will be open for access by the application users. Okay.